Okay, so for the second derivative test, we are looking at um, basically this is a redundant test if we've done the first derivative test, but we can use second derivative test to check for max and min. So if we have a first derivative equal to 0, so we have a horizontal tangent, we can check to see if it's a max or min by looking at the concavity or the second derivative. If the first derivative is 0 and the second derivative is negative, we know that's concave down. That means it must be a max point. If the first derivative is 0 and the second derivative is positive, we know that's concave up, which means that horizontal tangent must be a minimum. For inflections, we can check where the second derivative is equal to 0 and test the concavity on both sides of that. Now, it's important to test the concavity on both sides because to say it's an inflection, it must change concavity. So there are situations where we have a negative concavity. We end up with a 0 concavity here. Okay, but then instead of switching to positive concavity like that, it is possible that it goes back to negative concavity. Okay, and something like that would not be considered an inflection point. Although that's a 0 concavity, we have to have a change of concavity for it to be an inflection. And that can happen through a non-zero point as well. Okay, so we could have an abrupt change of concavity from negative to positive without actually going through 0. So that's something important to consider.